Hello friends, myself Saurabh Sharma. I am coming with the new questions number 7 of Pathfinder. So let's read the question. A material particle is chasing another one and both of them are moving on the same straight line, okay? After they passes a particular point, their velocity v varies at the time as t as shown in the figure. When will the chase end? So there is somewhere here they will collide. So question, when will the chase end, means finally when the chase will over, okay? So let's assume one thing. What is happening in this question? If I'm writing the simple thing, so there is a material particles changing to the another one at both of them. So what is happening? One particle is moving somewhere, another particle is moving from somewhere with different velocities, of course. But a velocity versus time graph is given. But uh, but uh, but both will cover equal displacement in case of chasing. So chasing in time t. So simply we can write, if I'm writing the displacement covered by first particle, if I'm writing the displacement covered by first particle from 0 to t, so it is a particle in time t is nothing but we can write the area under the curve. So let's assume it is moving. This is moving with the speed of v1 and this is moving with the speed of v2. So at this point we can write very simply, it is nothing but this area under the curve, area under the curve v versus time. So it is half of v1 into t. Okay, so it is half of v1 into t. This is the first way. Second way is, if I'm writing the displacement, I'm talking about the displacement covered by second particle in time t. So let's say it is second particle start the motion after t is equal to 3 seconds, means first particle start from t equal to 0, but the second particle is start from t equal to 3 seconds. So again we calculate the area under the curve. So if you calculate the area under the curve, then half of v2 into t minus 3. I tell you clearly, in case of chasing, this is x1 let's say and this is x2. So we can say that the displacement covered by both particles are same. That is means if I am writing the v1 and v2, so it is half of v1t is equal to half of v2 into t minus 3. Finally, you can say that this half of cancel and ratio of the velocities is t minus 3 by t. This is equation number 1. Okay, now the question is saying that at t equal to 4 seconds they collide. So time taken by the first particle to collide or chase is 4 seconds and second one is 1 second. Okay, so if for first particle we can write the v1 by t is nothing, it is equal to v naught by 4. Let's assume the v naught is the velocity, okay, and And if I am writing the value of V1, so V1 value is, it is V naught T by 4. This is equation number 2. And V2 for second particle, if I am talking about, for second particle, it is V2 upon T minus 3 is equal to the V naught by 1. So the V2 is nothing but it is equal to the V naught into T minus 3. Finally, we know we want to put these values V1, V2 in the equation number 1. So V1 is V naught T by 4 over V2 is, V1 is V naught T by 4 over V naught into T minus 3 is equal to T minus 3 by T. So finally, you V naught cancel, cross multiply, so it is T square is 4 times T minus 3 whole square. You can write, sir, T minus 3 is equal to T by 2. Okay, so T minus 3 is T by 2. So finally you can say that T by 2 is equal to 3 seconds. So T is nothing but it is equal to 6 seconds. So at this 6 second, we can say that the chasing will end. So finally after 6 seconds, they will not chase with each other. So the correct answer is 6. Thank you so much for watching this video. Please be in my